On June 12, 2025, the world watched in horror as Air India Flight 171, a Boeing 787 Dreamliner bound from Ahmedabad to London, crashed just 30 seconds after takeoff, striking a hostel near BJ Medical College. Of the 242 souls on board, only one survived, while over 280 people, including those on the ground, lost their lives. Which brings me to the core of today's project. After that heartbreaking crash, I went to the source, India's aviation safety regulator, the Directorate General of Civil Aviation. I downloaded the latest 15 accident investigation reports from the DGCA portal. This includes everything from the 1993 Airbus A300 crash near Tirupati to the Bell 206B3 helicopter accident at Kovadalanka, and the more recent mid-air collision involving an IL-76. All reports are publicly available on the DGCA website under Accident Reports. Before I dive into the technical details, here's what I'm actually building. And I'm building a system where anyone can ask questions and get answers from those reports instantly. So instead of manually reading through pages of dense PDF files, users can now interact with the data, like asking, what did the tests on the engine, fuel filter, and tailboom reveal in Kovadalanka accident report? Or, what was the weather and environmental condition at the time in Kovadalanka accident? Let me quickly explain what Memvid is, because it's the core tech behind our approach. Memvid originates from groundbreaking research in video-based AI memory. In essence, it turns text into QR code frames and packs them into an MP4, leveraging video compression to store and index massive text collections very efficiently. Overlay points, each text chunk, QR code, video frame. Video compression equals ultra-efficient storage. Semantic index equals lightning-fast search, even offline. Now, before I explain how Memvid fits into this project, let me quickly talk about the reality of the DGCA accident reports. Some of these reports are searchable PDFs, where the text is selectable and copyable, but many others are just scanned images, completely non-searchable. And that creates a challenge, because Memvid internally uses PyPDF2 to extract the text from PDFs. That only works when the PDF is machine-readable. So to handle this, I created a custom script called pdfextractor.py. This script uses PyTesseract for OCR, PDF2 image to render the scanned pages, and PDF Plumber to extract structured text wherever possible. The goal is to convert all types of reports, searchable or scanned, into clean Markdown format. Now, there is one limitation I have to mention. This process may lose some visual elements like graphs and tables, especially if they're complex or embedded as images. That's the trade-off we accept to make the bulk of the content usable and searchable. Now let's talk about one of the most important parts of this project, the data processing script. This is where all the Markdown versions of the DGCA accident reports are converted into Memvid's searchable QR video format. The script starts by looking into a directory, Data/Accident Reports 15 Markdown. This is where I've stored all the cleaned and structured Markdown files, each representing a single accident report. It reads through all .md files in that folder, using Python's built-in pathlib and argparse to let me customize the input and output folders easily. If there are no Markdown files, it simply stops and alerts me. Step 2. Setting up the encoder. Next, we configure the Memvid encoder using a default configuration. But I make some specific changes to ensure good memory segmentation. I set the chunk size to 2048 tokens. This defines how much text is encoded into each memory block. I add an overlap of 64 tokens between chunks. This helps preserve context across chunks, which improves semantic search later. I also choose the IVF indexing type, which is fast and efficient for large memory bases. These parameters are important. They affect both the size of the video and the quality of the search experience. Step 3. Feeding text into the encoder. Now, for each Markdown file, I read its content and feed it into the Memvid encoder using add text. This step essentially builds the AI memory graph internally. Step 4. Generating the video plus index. After loading all the Markdown content, I run the command build video. This generates 3 key output files inside the data current folder. The .mkv video file. This is the memory video itself. It's made up of QR code frames, each representing a chunk of the Markdown. A .json index file. This is a map that links each memory block in the video to its original content and position. A .faas index file. This is where all the embeddings are stored for semantic search. When I ask a question, the system uses this file to figure out which chunk of memory is most relevant. These 3 files together form the complete brain of the system. This is where static aviation reports are transformed into a scannable, searchable, AI-ready format, one that anyone can query, analyze, and learn from instantly. Now that we've created our memory video and indexes, let me show you how the search system works. This is where the real interaction begins. I've written a script called search.py. This script lets us ask natural language questions to the AI, and it finds answers directly from the memory video of the accident reports. The script begins by loading the environment using dodenv. It grabs the OpenAI API key securely from a .env file. This is needed because the AI response generation happens through OpenAI's models. If the key isn't found, the script raises an error immediately to avoid silent failures. Then, the script initializes a Memvid chat instance. This is the magic component from the Memvid library that connects the QR video memory, the text index, and the language model provider, in this case, OpenAI. You can also choose a different LLM or custom model by passing a model name, but OpenAI's models are used by default here. Finally, it uses the chat.chat method to ask a question. This searches the video memory and finds the most relevant chunks, using the .json index to know where to look, and the .faas file internally via the encoder. The result is returned as plain text, ready to show in your front-end, CLI, or fast API response. If you found this project interesting or useful, please hit that like button. It really helps more people discover this kind of tech-powered research. And if you're into AI, or just love seeing real-world applications of large language models and video encoding, then make sure to subscribe and turn on the notification bell. I've got more exciting projects coming up. I'd also love to hear your thoughts. What do you think about turning PDF reports into searchable videos? Any feature suggestions or feedback? Drop a comment below. I reply to everyone. And finally, if you want to explore the code, clone the project, or even contribute, check out the full GitHub repo. It's linked in the description below. You'll find the PDF processing code, Memvid integration, search functionality, and everything you need to try it yourself. Thanks for watching, and I'll see you in the next video.